All right, moving on to number 20. So it says the pilot sights the airport when his plane is in an altitude of 10,000 feet. The angle of depression is 15 degrees. And it wants to know what the air distance, the direct line between the plane and the airport. And so here they kind of already provided a diagram for you. The only thing we got to do is complete it. So I'm going to zoom into the diagram so we can take a better look at it. So here's the airport. Here is the airplane. Here's the direct sight. Altitude would be perpendicular to the ground or the bottom or the base. And they're telling me that that is 10,000. And they're also telling me that your angle of depression is 15 degrees. So depression means that it's the pilot, the one that's looking down, and that itself is 15 degrees. Now remember, angle of depression and angle of elevation are the same thing, because if you can kind of think of that as the starting point, or that's kind of like degree 0. When you look down, that's going to be 15. So if I do the same thing, if this is my degree 0 and I look up, then I can also create that same angle of 15. And that's important because I now have that same information here for this right triangle. And if you notice, I have an angle measurement. I have an angle measurement of 15, or in other words, I really have the angle of reference. And so that's how I'm going to label my diagram. If this is my angle of reference, and across from my angle of reference is always going to be the opposite side. Across 90 is the hypotenuse, and then the adjacent. Now if you notice, it says it wants to direct the air distance. So in this case, I'm going to label this, the hypotenuse, x. And so that's what I'm looking for. That's what I need. And so the equation that has both the opposite and hypotenuse is going to be sine. And so the equation I'm going to use is sine, with my angle of reference being 15 degrees. And sine is always going to be opposite, which in this case is 10,000, over hypotenuse, which in this case is x. And so remember, whenever x is in the denominator, we're going to switch these two things. And so I get x would be whatever 10,000 over sine of 15 is. And so that's exactly what I'm going to put in the calculator. And when I do put that in the calculator, I get x to be 38,637 feet. Alright, so moving on to question number 21. So number 21 says a tree that is 35 feet tall. So I'm going to go ahead and draw that. Cast a shadow that is 57 feet long. So shadow is going to be the horizontal distance. Well, I'm going to go ahead and label that 35 feet and 57 feet. And it says find the measure of the angle of elevation of the sun. And they want us to round to the nearest degree. So if we're looking for elevation to the sun, that means that this down here is what I'm looking for. So I can call it theta, I can call it x, really any variable I want. And so if that's if that's my angle of reference, I'm going to label it according to that. So across from my angle of reference is my opposite side. Next to it is my adjacent side. And so the equation that I'm going to use is tan, because tan has opposite, which is 35, over adjacent, which is 57. Notice how x is inside of tan, or in other words, I'm looking for an angle measurement. So that's telling me that I'm going to have to use inverse tan, or tan inverse. And so I'm going to put tan inverse of 35 over 57 into my calculator, and I get x to be, or the angle to be 31.5 5, but because they want us to round to the nearest degree, we look here, which means that the nearest degree is 32 degrees. Where it says calculation ready equation, that's the equation we put in there. Alright, 22. 22 says Jamie is flying a kite, okay, and he let out 100 feet of string. So 100 feet of string to the kite would represent that distance there. It says the kite string makes an angle of 55 degrees with her eye line. So that's going to be important because it doesn't say it's from the ground. It says from her eyesight. So this is her eyesight. Remember, horizontal distance, and 55 degrees is going to represent that angle there. And I want to know, how high is the kite above the ground, not Jamie, the ground. If Jamie is 5.5 or 5 feet 5 inches tall. So the first thing we got to figure out is, what is this distance here? Once we know that distance, we're going to add it to 5 feet 5 inches. Now the first thing we got to figure out is 5 feet 5 inches as a decimal. 5 feet is, 5 inches out of 12 inches, because that's what's going to give us the out of a foot, is 0.4167. And so this 5 feet 5 inches is going to be 5.4162 of a foot. And so back to this. So if this is my angle of reference, across my angle of reference is my opposite side, and then here's my hypotenuse. And so the function that relates both opposite and hypotenuse is sine. And so we have sine of 55 is equal to the opposite side, which we'll call x, over the hypotenuse, which is 100. Now, because x is on the numerator, we're going to take this number here and we're going to bring it to the front. And that's what I'm going to put in the calculator. So I put 100 times sine of 55 equals x. Put that in the calculator and I get x to be 81.9152. Now if I want to find the total height of the kite, I'm going to add the 81.9152 to the 5 feet, 0.4162 that I had, which gives me a total height of 87.3319. Now, it says round to the nearest foot. So because it's at 0.3, then it stays at 87 feet. Alright, moving on to 23. So for 23, we have a lot of information. So we're going to kind of highlight what we need. So it says, Coach Arthur is standing on the edge of a stage in the Commons. He sees Mr. Garcia sitting at the table in the Commons. The first thing to tell is that the stage itself is 3 feet from the ground. And then it says Coach Arthur's eyes are 60 inches. Now we have to be careful because here it's talking about feet, and now here we're talking about inches. So we had to do a little conversion. And it says it's from the floor of the stage. So not the floor, not the ground, but from the floor of the stage. And it says in the angle of depression, so that means looking down, from Coach Arthur's eye to Mr. Garcia's is 8 degrees. And we want to know how far Mr. Garcia is from the stage. And lastly, it says round your answer to the nearest tenth of a foot. So that means 1 decimal place. So we're going to go ahead and draw our diagram for this. And so here's kind of what it's going to look like. So here's my stage that I know is 3 feet. And 60 inches, so all we got to do is, we know 60 inches is his line of sight, so kind of like the tip of our triangle, if you would say. And if we're trying to find how many feet there is, well, we know that there's 12 inches and 1 foot. And so that gives me 5 feet. So here's Coach Arthur, such and such. Here's his line of sight. So that right there is 5 feet. And it says from the stage. That's why we drew it there. So then we also have Mr. Garcia that's sitting down across the stage, or away from the stage. So we're going to draw Mr. Garcia sitting down here. And it says that Coach Arthur has a line of sight to his feet. And they gave us an angle of depression. Now we have to be careful, of course. Remember, angle of depression is always going to be horizontally down. And so that right there measures 8 degrees. And remember, angle of depression, angle of elevation is always going to be the same thing. So if this angle of depression to the feet of Mr. Garcia's is 8 degrees, then the angle of elevation is also going to be 8 degrees. And so we have the triangle that we need. And so I have my angle of reference being 8 degrees, and this entire length, or that entire height, is actually 8 feet. And what we're looking for is this distance here to the stage. And so I'm going to label my diagram according to my angle of reference. So here's 8, which means across from 8 is my opposite side. Next to it is my adjacent side. So the function that's going to have both of these two things, opposite and adjacent, is tan. So I have tan of 8 degrees is equal to the opposite side, which is 8, over the adjacent side, which is x. And because x is in the denominators down here, we're actually going to switch both these two things. And so in my calculator, it's actually going to look like 8 divided by tan of 8. And so when I put that into my calculator, I get x to be, or the distance to be, 56.9 feet.